7.1 fundamental identities. We've got a lot of equations in this chapter, a lot. If you flip through the notes, you're going to see a lot of equations, and I'm not going to expect you to memorize them all. Some of them you probably will, though. For example, this first box, you should probably already have a lot of those memorized. We know that tangent is sine over cosine. We know those things. We know that cosecant is the reciprocal of sine. We know those. But some of the other ones maybe we don't know. So we have talked about the negative angle identities. This is when we talk about odd and even. And I don't know if I would spend a whole lot of time memorizing this, but how an even function works is something like this. If you've got some kind of even function, so let's say this parabola. If I plug in a positive x value and whatever I get is a positive number, then when I plug in the negative version of that same x value, I get the exact same value. They're even. And so how the formula works is when you plug in opposite values, you're going to get the same result. That's how that works for an even function like cosine and like secant. For an odd function, let's think about like a tangent. Okay, we know tangent looks like this from the last chapter. That's odd. And so what happens is if you plug in some positive x value, you're going to get a positive y value. But then if you plug in the opposite x value, you get the opposite y value. And so what that says is if you plug in opposites, your result is going to be opposites. And no, that's difficult to understand, but that's how it works. You can kind of figure that out. So you don't necessarily have to memorize it. The Pythagorean identities, though, are the only ones that we haven't really talked about right here. I don't expect you to have all three of them memorized, but you're probably not going to be able to help but to memorize this one. So sine squared theta plus cosine squared theta equals 1. That's something that comes up a lot. It's going to come up all the time. I don't have the others memorized. You will get a formula sheet at some point, but some of these you're not going to be able to help it. You're just going to memorize them by accident. Example 1, find trig function values given one value in the quadrant. Okay, we've actually done this problem before. If tangent theta equals negative 5/3 and theta is in quadrant 2, find each function value. When we did it before, we spent a lot of time on it in chapter 5, actually. We drew a picture of theta in quadrant 2. We needed x and y and r, and once we found x and y and r, you could give me any of the 6 trig function ratios, right? All right, so this chapter is different because we have these equations, these identities. And so how this is supposed to work, is you're supposed to look and you see a tangent and a secant, and you want to look at those equations and see if you can find an equation that has both a tangent and a secant in it. All right, take a second, look. Do you see it? Good. Tangent squared theta plus 1 equals secant squared theta. Write that down. Write it kind of small. This lesson, this whole chapter, really, there's kind of a lot of writing, I guess. So make sure you're writing small and writing neatly. All right. Now, one thing that causes a lot of problems in this chapter is people don't understand that all we're doing a lot of the times is just algebra. All right. So I want you to forget about the trig for a second and think about what this equation would look like if it was just algebra. All right. So don't write this down. I don't think you need to write this down. But if I took this equation and thought about it as algebra, it might be like t squared plus 1 equals s squared. We're a lot more comfortable with that because we're a lot better at algebra than we are at trig, but it's crossing over. It's the same thing here. And in the problem, the given information said that t was equal to negative 5/3. And so if I gave you a different problem and said t equals negative 5/3, t squared plus 1 equals s squared, find s, I think it would be obvious what you're going to do. you're going to substitute that number in for t. Make sense? So that's exactly what we're doing. We're just doing a substitution. We know that tangent theta is equal to negative 5/3, so I'm going to plug it in right here. I'm going to plug that negative 5/3 in, and I'm going to square it. And you can probably do that in your head. 5 squared is 25, 3 squared is 9, negative squared is positive. That's going to turn into 25 over 9. Okay? So just copy down the rest of the equation. Plus 1 equals secant squared theta. I want secant theta, which means I'm trying to isolate. Okay? Now, something that's going to come up a million times in this chapter is adding fractions. And I don't know why high school students are not very good at adding fractions, because you should be. But every time you add fractions, you're going to want a common denominator. Get that through your heads. Add fraction, common denominator. So I'm going to change this 1 into a 9 over 9 just so I can combine them. I'm going to combine those fractions into 34 over 9. Okay. So to go back to my algebra analogy, what I've got at this point is some fraction equals s squared, right? And at the end of the day, I'm just trying to isolate the variable. And you know how to isolate s. We're going to have to take the square root. We're going to have to take the square root of both sides. All right. We would take the square root of both sides, and that's exactly what we're going to do here, plus or minus. So make sure you do the plus or minus root, plus or minus square root on both sides. Plus or minus square root on both sides. So, excuse me, plus or minus square root of 34 over 3, because the square root of 9 is 3. I don't know the square root of 34, but I know the square root of 9, equals secant theta. Now, I could go farther and find theta, but I don't need to. I don't need to isolate theta. I needed to isolate secant theta. And I would be pretty much finished, except the plus or minus is talking about where we are. And we haven't really dealt with where we are yet. Remember how we said theta is in quadrant 2? All right, we haven't dealt with that yet, and we're going to have to. We're always dealing with what and where. So we're talking about a secant. And secant we know is the reciprocal of cosine, and cosine we know is talking about the x coordinate. So we're definitely talking about x numbers, right? What do I know about x numbers in the second quadrant? What? Negative. So really, I don't want the plus or minus root. I only want the minus root because we're in the second quadrant. Your answer will be secant theta equals negative square root of 34 over 3. Now, this method is good and it's useful, but it's way harder than what we did in chapter 5. Okay? Because the problem with this, what we're doing in chapter 7, is when I get to part B and I have to find sine theta, I have to have another equation and I have to do the whole thing again. Okay? With a different equation. Yes? Because how do I go from 9 to 3? Because I'm taking the square root. So I don't know the square root of 34, but I do know the square root of 9 is 3 right there. Yeah. Okay. So I'm gonna kind of cheat on this problem. I'm gonna do this problem again, except I'm gonna do this problem the way we would have done it back in chapter 5. This will be good review, but also I think you'll prefer doing it this way anyway. Okay. So chapter 5, what we did was we said, all right, we've got some angle theta in the second quadrant. So we drew an angle in the second quadrant. Angle theta puts us in the second quadrant. Okay, draw that. But what happened was that angle defined a point, and it also defined a right triangle. And that point, that XY point, defines this side, which is our y side, and this side's our x side, and this side is our r, our radius of that circle. As we rotate the angle around, it makes a circle. We've got x and y and r, and if you've got x and y and r, you've got everything. And so what we did was we said, okay, we know tangent is y over x. And so we know the y number is 5, and we know the x number is -3. And I know it's that way because it's that xy point. The x coordinate's -3, the y coordinate is 5. Okay, that makes sense. I've got x and I've got y. And then we had this formula for r, square root of x squared plus y squared. Maybe you remember that one. X squared is 9, y squared is 25. 9 plus 25 gives us that square root of 34 again. There's our number. We know x, we know y, we know r, so we should be able to come up with whatever you want. And so in this problem, when we had to do secant theta, we said, well, we know secant is the reciprocal of cosine. Cosine is x over r. This is r over x. R over x, square root of 34 over -3. Same thing, okay? The reason I like the drawing much, much better is because I'm all set to go. I've already done all the work for part B now. Sine theta, if you do part B, sine theta, we just have to know that sine goes with y. It's y over r, right? We can use that same picture and say the y number is what? 5, and the r number is radical 34. Very good. That's just not simplified. It's right, but it's not simplified. What? Okay, well, we fix it the way we've done before. We don't want that square root on the bottom, so we're going to multiply by square root of 34 over square root of 34. We're going to rationalize the denominator. We're going to multiply by 1. That's 1. And that's the only reason I'm allowed to do that is because I'm multiplying by 1 and it doesn't change my answer. All right, it changes the appearance of it. 5 square root of 34 over, remember how a square root times itself is just itself? That's it. Sine theta equals this. I think that's much easier than using one of the identities, okay? So I would encourage you to know how to do the formulas and using the equations, but you're probably going to rather do the picture. Now, when I look at part C, something jumps off the page at me. The negative, right? We're not accustomed to doing negatives, so it should stand out to you. Oh, wait a minute, we did something with negative angles. Maybe I'll go back and look at those formulas with negative angles, okay? Now, I don't need to look it up. I don't have them memorized, but I know cotangent, okay? I may not remember what cotangent is, even or odd, but I know what it looks like. Cotangent looks like this, right? That's a cotangent. And remember how I told you to tell is imagine this is kind of the body and the arms are, well, it's detached, but this is an arm and this is an arm. One's up and one's down. That means this is an odd function. So, I mean, you can go look at your equations, but cotangent is definitely an odd function. And so what that means is if I change this argument, then I change this result. Okay, different argument, different result. Opposite argument, opposite result. That's odd. Okay, one's up, one's down. Okay, so how can I do this? Well, we'll look at your picture. We know cotangent is x over y. So we'll have negative x over y. And then remember your x number was -3, your y number was 5, and your r number was square root of 34, right? So we've got negative -3 over 5, that's 3/5. Cotangent negative theta equals 3/5. All right, best way to do it is with that picture. Okay. Talks about a common error when taking the square root. You choose the sign based on the quadrant. So that's just when you get a plus or minus, you've got to think about the quadrant so you know which one to pick. All right. Is it positive? Is it negative? Where are we at? How do we know? Like that. Okay. So example 2 says express cosine x in terms of tangent x. So here's another reason why people struggle with this chapter is they don't know what that means. They don't understand express cosine x in terms of tangent x. All right. So I want to give you kind of an example where you've done this before. If I gave you that equation and said express y in terms of x, I would expect most of you to get that right. Express y in terms of x means I want y equals blah, 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 something x, okay? And most of you can probably rearrange that in your head. You're going to get 10 minus x or 10 minus 2x or negative 2x plus 10 or something like that. But that is y in terms of x. So in this problem, when it says I want to express cosine x in terms of tangent x, that means, don't write this down, I'm going to want cosine x equals blah, 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 tangent x. That's what I want. Cosine x equals something, 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 tangent x. I don't want a sine. I don't want anything else. I just want cosine x equals blah, 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 tangent x. That's what I want. Okay? Now, make sure you write small here because we don't have a whole lot of room. What I need to do is try to find one of my equations that's going to link those two. All right, I need an equation. Ideally, it'll be an equation that has a tangent and a cosine in it. Okay, so you might be looking at tangent equals sine over cosine, but the problem is I don't want that sine. Ideally, I want one with just a tangent and a cosine. Now, we don't have one, but if we do it in 2 steps. So we can actually start with the same one that we used before. If I go tangent squared x plus 1 equals secant squared x, what can I do in a second step? Reciprocal of secant is cosine, right? I can change that secant now into a cosine and do it that way. All right? So there's a long way and a short way, and I'm not sure which way you would understand better. If you understand it's the reciprocal, you just take the reciprocal of both sides. You got this, okay? Most people, if you're just looking at those formulas, you're going to say this is 1 over cosine squared x. Okay? And so most people are good here, but then they kind of shut down because it's the algebra. You're tripping over the algebra and you don't understand what to do next. And I would encourage you, if you get stuck, to just take the trig out and just look at the algebra. So if I took the trig completely out of this problem and just look at the algebra, it says t squared plus 1 equals 1 over c squared. That's what the algebra would say with no trig in it. And what we're trying to do is isolate the c. We're trying to get c by itself. So you got to solve this thing for c, however you want to do it. So there's multiple ways of doing it. I think most people would understand if I multiply both sides by c squared, I want to get that c off the bottom. If you understood how to do reciprocal, you could maybe skip a step here, but most people would rather just let's multiply both sides by c squared, get that c squared off the bottom. So that's what I'm going to do over here. I'm going to multiply both sides by cosine squared x. It's just algebra. It doesn't have to be rocket science. It's just algebra. We're manipulating stuff. And so, really, I don't have much to do just yet. I just canceled that out, and that's going to equal 1. So I'm looking at c squared times t squared plus 1 equals 1, right there. Now, again, if you're confused by the trig, look at the algebra. Look at the algebra. Okay, if I want to isolate the c, sometimes people are like, well, let's distribute the c squared, and that might be a good idea at some point, but not this time, because if I distributed the c squared, I'm going to have 2 c's. I don't want 2 c's because I want to isolate. That means I only want 1. Anybody know what I'm going to do? I'm going to divide by this expression to cancel that out. If I do that, I'm going to have c squared equals 1 over t squared plus 1. That's my algebra. So I'm going to divide by this expression, tangent squared x plus 1, so that all that cancels out. I've got cosine squared x equals 1 over tangent squared x plus 1. And I'm not done yet because I don't have c by itself. I haven't isolated. So if you're confused, look at the algebra. What's my last thing I'm going to have to do to isolate c? I'm going to have to square root both sides, right? I'm going to square root plus or minus. I'm going to square root plus or minus both sides. Now, they didn't tell me what quadrant we're in, so I don't know which one it is. I'll just leave it as plus minus. I'm going to square root plus minus both sides. Okay? That's going to give me cosine x equals, now I've got plus or minus square root of 1. I know the square root of 1. Square root of 1 is 1, so this is going to say plus or minus 1 over square root of tangent squared x plus 1. And this leads to an algebra confusion. Okay, there's something confusing about this algebra. People are like, well, wait a minute. Why did you get to cancel out the squared on the cosine, but not the squared on the tangent? Okay, and it has to do with algebra. So let me be clear here. If I did, okay, so go over here with algebra stuff. If I did the square root of 5 squared, okay, what's the square root of 5 squared? 5, correct. If I did the square root of 5 squared plus 1, that's going to be the square root of 26, is it not? Whatever that is. It's not going to be 5 plus 1 is 6. That's not how it works. It has to do with order of operations. So you're going to have to see that we're going to have to add that 1 before we take the square root. And so that's what happens down here with this tangent squared. This plus 1 is kind of screwing things up. We're going to have to add this 1 before we can take the square root. That throws everything off. We can't knock out that square. All right? But here it was fine. Square root squared cancels out. Okay? Now, I'm almost done, but there's one more step, and it's kind of gross. We've got a square root on the bottom, and we know how to get rid of that square root. We're going to multiply by the square root over the square root. Okay, so it looks grosser than it actually is. We're going to have to multiply by the square root of tangent squared x plus 1 over itself. By the way, that's 1, right? I'm multiplying by 1, so I'm not changing the value. So let's see what that equals. Cosine x equals plus or minus square root of tangent squared x plus 1 all over, remember, a square root times itself is itself, right? Tangent squared x plus 1. Think about all of the different little traps that you could walk into there. Okay, there's a lot of stuff going on. You got to know the trig. You got to know your equation to use. You got to figure out which equation to use. But you've also got to do a lot of different little algebra things. You got to isolate. You got to take a square root of both sides. You got to rationalize. There's a lot of different ways to mess up. So you got to be really, really careful, but you got to be solid on your algebra. Number 3. Okay, this is probably the most important example because this thing is going to happen a lot. Write tangent theta plus cotangent theta in terms of sine theta and cosine theta, and then simplify. So we do this kind of a lot. We're going to take the problem and we want to write it in terms of sine and cosine, meaning that's what I want to see. I want to see sine and cosine. So we're going to do a substitution. We're going to do another substitution. But basically what we have to do is turn it into sine and cosine. So look at your equations. Tangent theta Do we have an equation that's going to change tangent theta into just sine and cosine? Right, and that's exactly what I'm going to do. Tangent theta is sine theta over cosine theta. Okay? Right, it's the reciprocal, cosine theta over sine theta, like that. Okay? So, very important skill is to just change stuff into sine and cosine. And that's not very hard. We can do that. The harder thing to do in this problem is to simplify. So, you probably don't see what to do here. Yes, question. It was, which equation did we use? It was the very first one. The very first basic identity says tangent is sine over cosine, right? And then cotangent is the next one, is cosine over sine, right? No, you can't cross multiply. Hey, stay with me. Okay? If you don't know what to do, I would encourage you to forget about the trig and just look at the algebra. All right? So if I take out the trig, this problem says something like this. I'm trying to simplify an expression that looks like that. All right? I'm adding fractions. So you're going to see it a whole bunch of times in this chapter. When we add fractions, we need a common denominator. Okay? If I'm adding fractions, I need a common denominator. I have to. So in this algebra problem, you'd say, well, this one needs an S, so I'm going to multiply by 1. And this one needs a C, so I'm going to multiply by 1. Doesn't really matter what order you do, but I like to try to put them in the same order or whatever. So cleaning up this fraction on the left, I have S squared over SC. And this fraction on the right says C squared over SC. And if you really know what you're doing, you'll skip a step because you're going to see that those two fractions go together. We can combine those into a single fraction now, S squared plus C squared all over SC. That's the algebra. That's what's happening in this problem, and I don't think that's that tough. Okay? You got to be able to see it, though. If you can't see it, then you're going to struggle. All right? So, looking at this problem, I'm going to do the exact same thing. This one over here needs a sine theta, so I multiply by 1. And this one over here needs a cosine theta, so I multiply this one by 1. It's not a square. Sine squared theta on the top over sine theta cosine theta. Cosine squared theta, yeah, over sine theta cosine theta. Okay. And then we want to combine that into one fraction. We know we can put that together into one fraction. We're almost done. I like this problem a lot better than the last one. Doesn't cancel, right? It's going to combine. Sine squared theta plus cosine squared theta all over sine theta cosine theta. Okay. Now, if you can get to there, we're almost done. Now, there's one more thing that we can do. So look at your equations. Look at your equations and see if you can see one pop out. I might have told you to put a star by it. Sine squared theta plus cosine squared theta equals 1. So what we can do is we can say that whole numerator equals 1. And we're going to say 1 over sine theta cosine theta. Okay? This chapter is challenging, but it doesn't have to be rocket science. You have to think it through and really be tight on your algebra.